What is going on, guys? Welcome back. In this video today we're going to learn how you can build your own simple search engine in Python using language models. So let us get right into it. Alright, so we're going to learn how to easily build our own customized search engine in Python today using language models. Now, just to clarify this right away, we're not going to build a search engine for the internet like Google, Bing, or DuckDuckGo, for example. This is going to be a search engine for our own data sets. So, for example, you might have a data set full of movies with titles, descriptions, and so on, or of products, or of blog posts, something like this, and you want to search them with your own search engine. This is what we're going to learn how to do in this video today, and it's a very easy process because we're going to use an external Python package for this called txtAI. So we're going to use pip or pip3 install txtAI. In addition to that, we're also going to install NumPy and pandas just to work with some data sets here, and we're going to also build this into a web application. So we're going to actually have a user interface with the search engine or with the search field. And for this, we're going to use Streamlit. So these are the packages that we're going to need for this video today: txtAI, NumPy, pandas, and Streamlit. Once you have all of this installed, let's start with the simple act of embedding the items into a vector store and then searching the items based on a similarity search, basically. Now for this, I use two data sets in this video today. Here are the links. You're going to also find them in the description down below. We have the Amazon product data set and the Seth Godin blog post data set. You can use, of course, whatever data you want. I just wanted to use some data that has a lot of text, like titles of products or descriptions or blog post content, something like this. So what we're going to do first is we're going to import txtAI, we're going to import NumPy as NP, and we're going to import pandas as PD. And then we're going to load the dataset from Amazon first, which is here. I extracted it already, the train CSV file that you're going to find on Kaggle when you download the dataset. And for this, we're going to just say df equals and then pd read underscore csv train.csv. This just loads the dataset and we can print it to see what it looks like. And what you will see here in a second is the dataset once all the importing is done. This TensorFlow message here is because we import txtAI. But then pandas is going to load the CSV file and hopefully display it here in a second. But I can already tell you there's going to be a field title which contains a lot of information about the product already. So it's going to be the full Amazon title of the product. Okay, actually it doesn't show it here. So maybe just to show you what the field looks like. Now, if you want to explore it yourself, you can just go and say print df columns. And then you will see that there's a column title in caps. And this is the one that we're going to use for our search. So we're going to take the title of all the individual items. And then we're going to embed the title itself, which is not just two words. It's a description of what's actually, what the product is actually about. We're going to take that title, we're going to embed it into a vector store, and then we're going to use that as our database. So you can see here, these are the titles of the products, and this is what we're going to embed. So in order to not use all of the data set, because it's quite large, we're going to just limit our selection here to 100,000 items. So I'm going to say here, and to keep this consistent, I'm going to set a random seed. So I'm going to say np random seed 1, just so that when I do a random sample, it's always the same random sample. So what I'm going to do is I'm going to say titles is equal to df. We're going to drop all the nan values, and from the remaining values, we're going to sample 100,000. And from those, I'm going to just get the titles as a list. So title.values. This is just now 100,000 randomly selected titles from the dataset, but always the same. So every time I run the script, I'm going to get the same selection. Now, to turn this into a vector store, or to embed these titles into the vector space, what we're going to do is we're going to say embeddings is equal to txtAI embeddings. And now what you want to do is you want to provide the path to a Hugging Face transformer that is compatible. Now you can look up the package if you want to try some alternatives. The one that we're going to use in this video is going to be sentence-transformers /all-mini lm-l6-v2. And I think there's also an L12. Maybe we're going to try this later on. But this is now just the link to a Hugging Face transformer. So on Hugging Face, under this URL here, you will find a transformer, and we're going to use this transformer model to embed our titles into vector space. And then we're going to say embeddings.load embeddings tar gz. And now we can try also, to have a search prompt. So let's say I want to search in the embeddings. Once they're done, I want to do embeddings.search. I can enter a search phrase. So for example, protector for cam. And I can say that I want to have the top 5 results for this query. And then I will get the actual results by saying, actually, I can show you why I do this. We can print the results in between. But to get the actual text results, we're going to do titles. Come on. First of all, let's remove the S here. Then titles, and then x0 for x in result. Now, why do we do that? Because the result is going to be a collection of indices, because we're not going to get the text as a result. We're going to see, okay, which index of the titles is the one that fits this the most. And then we have to look up the actual title by providing the index. And the index is going to be stored in each result object in the first position. So this is the result object. Index 0 will have the ID. And for this ID, we want to get the title. So this is the actual results that we get here. And we can print them. And that is actually the whole magic. Now, this is not the application yet, but this is the process. We load, we embed, we search, and we get the results. Now, this is going to take some time now. Meanwhile, we can discuss what we're going to do now next. We're going to build a Streamlit application. And a Streamlit application is basically, I have a video on this channel where I explain how to build Streamlit applications, but it's quite simple. You just provide the UI elements and you say how they are connected. Now, what's the problem here? Oh, of course, sorry, I have to not load the embeddings here. We load the embeddings, of course, in the actual application. We need to save the embeddings so that we can load them later on. So actually everything else is obviously going to be the same. So we save the embeddings, and later on we're going to then load them. And also, before we save them, we need to say embeddings index the titles. So that's the order here. We, yeah, of course, I didn't do, yeah, this was stupid. I didn't do the actual work here because, let me repeat this again. We load the data set, we get the titles, we say that we want to have this embedding model here. Then we need to do the actual embedding on the titles, obviously. Then we need to store them, and then we can use them. So I skipped basically the most important step where we actually embed the data set. But let's get back to Streamlit. So what we're going to do in Streamlit is we're going to just define the UI elements, and we're going to say what happens when you press the search button, or what happens when you, when you enter a search query. We're going to have a request for the database, then we're going to get the result, and we're going to display it in a UI. And then basically the functionality that I'm showing you here is going to be done in Streamlit, but we're not going to train all of this again. We're not going to embed all of this again. We're going to just load it the way I actually did it here by mistake. So while this is happening, I can already create now a second Python file. Let's call this main_streamlit py. And here now we're going to say import streamlit as st, import numpy as np, import pandas as pd, and also from txtai.embeddings, or actually, let's just say again, import txtai, the way we did it before. And now what we're going to do is we're going to define what we did now with the embeddings. We're going to define this as a function with the difference, of course, that we don't index and save, but we load. So I'm going to say load data and embeddings. It's going to be a function. And we're going to say here np random seed. As you can see, this takes some time down here. We're going to provide seed1 again so that we have the same data set. By the way, there you go. You have now here the search results. These are the indices for the most fitting items. And whether they're good or not, we're going to examine that in the actual web application. But you can see already that we have here some screen guard, we have some camera lens protection, so it's not definitely not something that doesn't fit at all, because the prompt, remember, was protector for cam. So this makes sense. So let's continue here. We're going to load the same data set. It's important that you set the same seed because you want to load the exact same 100,000 samples. Now, this is, of course, only important if you use samples, if you don't use the full data set. But in our case, we use 100,000 samples. So you want to also use 100,000 samples, and you want to use the same 100,000 samples here in the application. So PD, read CSV, train CSV. And then we're going to say titles, again, is equal to df, drop all the nan values, and then sample 100,000, get the title, values. Then again, embeddings is going to be equal to txtai embeddings. We're going to provide the same path. This is important, of course. Sentence, transformers, all mini lm L6 v2. And now we do what I did by mistake before, embeddings load embeddings. Come on, why is this always lagging? tar.gz. So we'll load what we exported here. So we have the same embeddings, the same data set, the same titles, and all we want to return here is just titles and embeddings. Now for the Streamlit application, it's not at all complex. So what we do here first is we say titles and embeddings are going to be equal to st cache data. We need to cache the data. And we want to say load data and embeddings. We don't call this. We just provide this, and then we call the result of this cache data function. So we don't call our function itself. We pass the function, and then we call the result of this here, which is going to be a callable, obviously. Then we can just provide a title here. Let's say it's our text search engine, or let's say Amazon item search engine. Let's call it like this. And then let's say that our query is going to be equal to st text input. So we want to have a text field where we can enter a search query. Enter a search query. And the default is going to be an empty text. And then we're going to say if st button, this is going to now be the search button here. If this button is pressed, this is how you say that basically. If st button means when the button is pressed. If there is a query, if there is a text input, we want to say result is equal to embeddings search whatever the query is, and the top 5 results. Now we need to get again the actual results here, which is going to be equal to titles x 0 for x in result. And then for result in actual results, what we want to do is we want to write the results down below. And otherwise, we want to write please enter a query. So that is our application now. Again, to just recap, we load the data and the embeddings in the same way that we did before. We load the embeddings instead of indexing and saving them. We get them here, we cache them, we define that there is a title, we define that there is a text input, and the result of that text input is stored in query. If the button search is pressed and there is a query, we just search the vector store, we get the actual results, and we write them down into the user interface, and otherwise we just say please enter a query. So let's run this, but in order to run this, of course, we don't just run it the conventional way, we need to say Streamlit run. So we need to go to the actual directory here, and we need to say Streamlit run and then main underscore Streamlit. And this is going to open up the web application here. And if everything went fine, if I didn't make another mistake, we should be able to get the results here. Now you can see it's running the load data and embeddings function. So this is actually loading now the data set from disk. It's also loading the embeddings and yeah, basically the tar.gz file. And this can take some time, but once this is loaded a single time, we don't need to repeat this process. We can just run it once and then we can use our search engine. So let's go and say protector for cam search, And then you can see here we have the titles. Now, of course, in this case, we're just displaying the titles. It's not difficult to also display the URL, because in this case, all we have to do is we have to go to the data set and we have to get the right indices, and we can also get the URLs or something like that. It's not too difficult to do that. It's actually quite straightforward. And maybe we can do that. I'm going to do that with the next data set. I'm going to do that with the blog post data set here. But that is, as you can see, we have here camera lens protector. We have another protector here. We have some back protector with camera lens protector and so on. Maybe if I go laptop gaming, I'm not sure if I'm going to find something here, but let's see. We get here Lenovo IdeaPad, gaming laptop, gaming laptop, gaming laptop. And it doesn't have to be the exact keyword. So if I say laptop game, maybe I will get now video games, but maybe I'm going to get still a gaming laptop, even though the word game does not occur there. And also, I don't think, oh, actually laptop occurs, but game does not occur. But here, for example, we have a mini laptop for kids English study game. So that's again containing game. And here we have Game of Thrones with laptop skin. So it's not perfect, but you can see it works. And depending on the model that you use for the embeddings, it's going to work better or worse. So let's now change this to work for the other data set. And for this, let's go back first to our main file. The only thing that we're going to change here is that now we're not going to use a sample because this data set is a little bit smaller. I'm going to say that I want to load the Seth data. This is just a blog post collection of Seth Godin, which I found on Kaggle. So we load the data set here and we just drop the NaN values, and then we can use all of that. And what we're going to use here is we're going to use the content. So content is going to be equal to df. And again, we can print the column names to see what is part of the data set. I already know it. You can just print df columns. But I'm going to take the content plain value. So what I want to do is I want to index the actual contents of the blog posts, not the titles and not the URLs, but the actual content. But I can still access, when I get the results, all the other fields as well. So content is df content plain values. I use the same embedding model, and here now I'm indexing content. Now we can say embeddings Seth targz, and I can use another search query, for example. Or actually, I'm not going to even use the search query here. I'm just going to save the model. So this is going to hopefully work, unless I didn't do something properly here. But what we can also do now is we can adjust our Streamlit application, because our load function is going to be different, of course. We're not going to need a seed anymore. We're just going to drop an A. And we also don't want to actually display the contents of the blog post. So we don't really care about the thing that we're indexing here, because the indexing part and the search part is separate from the actual displaying. So we don't even need to have the content loaded here. We just need to say df is actually, let's do it here, drop an A, and here we're going to say df titles. So df title values, and URLs is going to be equal to df URL values. So these are the things I want to display. I want to search based on the content, but what I want to display as a result is titles and URLs. And then I use the same embeddings model. Then I load embeddings Seth targz. I do the same thing here. And then I just go, I can change this to Seth blog post search engine. And now what I do is, actually everything stays the same. The only difference is now that I don't actually return this. But what I do is I say formatted string title, and then I can use titles x0 to get the title. And URL is going to be then URLs x0, because remember x0 is just the index of the thing that we need, and of course we need to here return URLs as well, otherwise it's not going to work. But now we get a different result. So let's go back to our terminal here, let's rerun this, and let's see if it works. Okay, I made one important mistake. Obviously I loaded the same data set as before. We need to load Seth data CSV here as well. Otherwise, it's not going to work. So now we have to restart this and wait again. All right, so now it seems to work. We can just enter a search query. For example, let's say productivity tricks or something like that. I don't know if there is a blog post for that. But there you go, the productivity pyramid, and then we can go to the blog and see what we have here as part of the blog post, and maybe the productivity gap here. And what I can also do is maybe I can say book recommendations if I'm interested in that. Search, and then you can see here book list or a big week for books. So here I will get book recommendations. And even if book does not occur in the title, for example, here more than 12 minutes, I assume it's going to be part of, there you go, unlike most books that cross my desk. Or here we have a reading list, even though book does not occur here. So this is also because book list occurs in the content. Yeah, so one more thing that I want to show you is we can change the model. So we can change this. One easy thing to do is we can change this to, what was it, L12. I don't know if L12 is going to be more powerful, but there's also entirely different models. So we can also use, for example, the paraphrase. What was this train? Paraphrase dash mpnet dash base dash v2. And of course, the important thing is if you want to change them all, you have to do it all over again. So you have to do paraphrase dash mpnet dash base dash v2. You need to run this script again to do all the embeddings with this model first, and then you need to restart the application and load the new embeddings here as well. So I'm not going to wait and show you this now, but this is how you do it. So you change the embeddings here, you train, or you do the embedding process here again, and then you also change it to the same model here, and you load the embeddings and you use the application. But this is how you build your own customized search engine in Python. So that's it for today's video. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you very much for watching. See you in the next video and bye.